This is a very fun question also on how you can use the three light rays that I've taught you to figure out the answer. And in addition is on virtual image. So virtual image usually is more abstract for us to comprehend. So therefore, there are a few questions in the worksheet that deals with virtual images. So you are told that the image, sorry, the object is of height 1.5 cm, is a diagram is supposedly drawn to scale, and the image is 3 cm. You're supposed to just draw one light ray to figure out where is the position of the image. So when I see the word magnifying glass, immediately I must be able to realize that this is a scenario where we form a virtual image. So the image will be somewhere on the same side of the object, uh, same side of the lens as the object, somewhere here. And magnifying glass means it's bigger, so it's behind over here. So with that in mind, the one light ray that I will draw is this. So I just connect the arrowhead to the principal axis of the lens and straight line over here. Now, I'll extend the line for virtual image in the case of magnifying glass. Refer back to your ray diagram. Always extend back the line and use dotted line because this is not a real light ray. It's a virtual light ray. So this is what I'll do. And then given the information that the height of the image is 3 cm, I will just try to find and measure to scale a 3 cm image over here. And once I've gotten a 3 cm height image, I will just lock in the position. That is the position of the image. A point to note, your virtual image must be drawn in dotted lines. Please double check this in your workings. In part 2, then draw a second light ray to find the focal length of the lens. Very similar to the previous question. So again, draw a horizontal light ray parallel to the principal axis, and then when it bends, it will supposedly bend towards the focal point. The thing is, I do not know where this focal point is. So I can only start by connecting where my laser pointer is, this point, to the image position. So I will connect here to draw this dotted line, extend it into a solid line that cuts through here. All right, so once I've done that, then I can then figure out the accurate position of the focal point, which is over here. That's how you can solve this. Now in part B, the magnifying glass is moved nearer to the arrowhead. When I move this magnifying glass nearer to the arrowhead, or when I move the arrowhead nearer to the magnifying glass, is the same thing. What happens to the image? So if you notice, when I shift the object towards the lens, or the lens towards the object, there's no change to this horizontal light ray. No change at all. All right, so this virtual light ray will be the same, but this second light ray, the light ray that passes through the optical center will be steeper if I shift the object nearer. If it's steeper, it means that the image will be formed closer to the lens and it will be probably smaller. So let's just take a look at how is the image like when it becomes smaller and moves nearer to the lens. Okay. So now I will shift the object nearer to the lens. You see the image becomes smaller and nearer. All right. So that's how we can solve this question.